Hello, this is my Twitch streamer analysis by Brian Huynh. The questions I want to ask about this report would be the typical use of Twitch revolves around a user following a few set of streamers, and these streamers kind of all have the same characteristics with each other and are often quite irrelated. I want to ask what drives these communities and what drives like these niche viewing angles, and what type of communities exist as well. I also want to know what the best method for third parties who want to spread information on this network would be, and also what type of role does the community play in spreading information. For this network, the streamers are nodes themselves, and the links are the mutual followers between them. The weight of it is the number of mutual followers. Additional information about the streamers was also introduced, like their language and preferred category. The result of this network is a directed graph with 831 nodes, 7,850 edges, and an average path length of 2.68, and consists of a single connected component. Here we can see the degree distribution. The null model that I used was a degree preservation null model, and the random model is the Erdős-Renyi model. For the degree distribution in blue, we can see that it does not resemble the RAM network, which is a parabola. From the degree distribution, we can see that it generates a stretch exponential sublinear graph and not a linear parallel graph. So it's not truly a scale-free graph network. Here we can see the clustering coefficient. From the graph, we can see that there's a high clustering coefficient, and this is not replicated in the random or null model. So there's something unique within our graph. We can see this later as it emerges from a tightly knit community structure present in this network. So that we can see that there is a form of community structure that's present in the network. We want to see what drives this community though. If we run the greedy modularity function, we have a value of 0.7. So this is a very community network type. Starting to infer our own type of communities, I started by trying to figure out what these communities might be structured by. First off, I tried to see what streaming category and categorize them by that. This came out to a modularity value of 0.4. There's some limitations with this where the top most game of the streamer was applied. I use like a greedy approach where to maximize M by swapping around nodes with their top 5 games, I feel like I can maximize this to a higher number. But the value of 0.46 is high enough and significant to see that the game that they play or the category that they stream plays a huge factor in what community they are in. Next, I split them up into what language they spoke, and this came into a value of 0.73, which is very large. I feel like this is a very wide casting net that's easy to find. As we can see that it doesn't capture that much detail though. It's very general. As we can see, like in the English department, in the English network, there's actually 2 parts of the English network, but that's not covered here. Next, I've tried to categorize them by the category and the language that they spoke, and this came into a value of 0.4. So we can see that both language and the category that they stream plays a huge factor in what community they are in. And finally, for comparison, I tried it on the null model, and it came out at a 0.2, significantly lower than the modularity we see in our real network. So we can see that all of these values are properties of the network itself and not because of the type of network. Next, I want to analyze what was the best method to spread information on this network. I used the spread algorithm that we discussed in class, and I tried to check for 5 different methods where it would be random, top out degree, betweenness, closest, and eigenvector. There are 2 significant ones that I want to talk about for this. When starting with a single node, I found that the best method was the node with the highest number of outward connections, starting off at around 35% coverage. But we quickly see that high betweenness values jumps to 50% after a few iterations. After the initial jump from all types, we see a linear progression. This follows the principle of spread that adding new nodes at some point doesn't increase the rate of change. Looking at how information is actually going to be spread on this network, if a streamer says something and then the chat replicates it, they will go to other streams and replicate that meme there too. The chances of the meme spreading will be determined by the amount of people in chat who have transferred over. This was the foundation of how the probability function in my spread analysis worked. So we have two top contenders here, high out degrees and high betweenness. My hypothesis for the high out degree ones, the top ones, spreads faster early on, since it's almost guaranteed that it will affect its local community, especially if it's the English subgraph, because we see that there's a lot of high degree streamers in that graph. It's in the Korean one too. Um, this would be akin to like bus stations. It would spread quickly in its local community, but not so much in other communities. If we look at the betweenness graph at the bottom, we can see that there are nodes at the edge of every network. This allows for it to not only spread to one community, but also affect other communities that are in close proximity to it. This would be akin to airports, which will allow it for to spread across different communities, but not necessarily spread quickly within a single community. Taking a closer look at the betweenness values for the degrees of highest betweenness and outward degrees, we can see that in the betweenness category, we see a very large variety of languages and top categories. And that plays a huge part in what I talked about for the community structure, that these two elements play a huge role in what community they are in. When we look at the high degree, we see that they're either Korean or English, and also there's a very limited number of streaming categories. Um, Now, visually representing this network, we see on the left we have the top degrees, and on the right we have the betweenness. If we look at the top degree network, we see that it's very quick to affect its local community, especially if you look at the right nodes, those are Minecraft streamers, and from my analysis, I found that they were very tightly connected, and because of that, they weren't able to spread it to the top and bottom nodes, which I believe were the Japanese and French streamers. If we look at the betweenness nodes, we can see that there's like one node in kind of every community, and this allows it to have a local representative of that community to spread that, and we can see that it spreads a lot more effectively, able to reach other communities, while the one on the left does not.